Hello everyone. Very good morning.
Morning.
Morning. Okay. I think I joined too early today. We will wait for 2-3 minutes.
Hey Ashish.
Yeah, hi Dennis.
Yeah. Ashish, like I'm getting an error in MongoDB, so can you please
Uh,
help me out in the end of the session?
do you have that handy right now?
Yeah,
What
yeah,
it is?
I do.
Okay, let while people joining, let's try to do that. We have 2-3 minutes more because we have
Sure.
only 7 people here. Let other
Okay.
people join.
Sure.
Um,
And I think it's yeah, 1 minute. Yeah, can you see that? Can you see this?
mhm. Yeah.
Yeah, so like this is the error. Like I'm getting an invalid syntax error here. Like I'm changing everything into the
Oh, okay. Business, I think I
Mhm,
have changed this file. Okay, you have to refer the new file that I have provided. Can you do that?
mhm.
Because
Sure,
this
fine,
code
sure.
reference, yeah, reference one to many and reference one to one. I think I have updated this text file, not embedding,
Okay.
reference one to one.
This
Reference
one, right?
one to one.
One to one, right?
One to one and one to many. Both I have updated. So yeah, so I have already modified the query according to the Jupyter notebook so that
Yeah,
that
in this only I have opened.
that ISO should not be okay. Just a minute.
Hmm
Hold on a second. This is one to many, right?
hmm
Uh,
And for the
this
second collection also the same thing was happening, like unhashable list.
uh, I think Divya also tried, right? Uh, Divya is
Yeah,
there?
yes.
Mm, So mydb dot insert one, right?
Yeah.
Uh, invalid syntax is what? Deadline. Deadline with ISO. What you are getting the error? Can you go up? Go up. Is it written in the
Uh,
same way that I have pasted in that? Can you
yeah,
verify?
yeah, yeah.
You copied
This,
from here, is it?
yeah,
See,
I've copied it.
see, ISO date you have given some quotation, but here it is not there, right?
Yeah, the reason is because like I've tried it without that also.
Look, you copied the whole from there. Don't give anything, just copy it totally
Okay,
from there.
okay, sure. Copy and let me replace it here.
Huh,
Uh, and now I supposed to give the quotations, right?
huh. Uh,
Name, deadline, and name, ID,
just a minute.
deadline.
Is it 1 second, Dinesh? Let me just quickly verify. Is it the same
My
file?
DP.
Because I have updated it. Just a minute. Give me one
Mhm.
second.
Sure,
If not, we'll do it at the last
sure,
minute.
sure, sure. No
Just
problem.
let me quickly verify. What is the session number? Can you help
Yeah,
me out?
let me give it. Session 18.
Session 18, 22nd June. Okay. Data relationship. Reference one to many. Uh, okay. This is the
Do we have insert many was just like that only, now? I mean, insert
uh,
underscore was there or no?
insert many is for no, actually this file got modified. Insert many is for MongoDB. Not for Jupyter notebook. So what did I change then? Is it reference one to one? Reference one to one, I think I changed. But why not? Dinesh,
Yeah,
do try with reference one to one and see whether you are getting an error or not.
sure.
Reference one to many, I
Reference
think.
one to one, right? Let me do it.
Reference one to many, I think this is not the updated file. And I'm not sure. This is not the updated file, but I have done it. Let me verify. Okay, let me verify. But reference one to one will work. Okay, guys, please try with that.
Okay, my DB is supposed to change here. My DB.
Ashish, one input for that ISO date thing.
Hmm.
There were a double quote, ISO quote, ISO date, and then brackets without any quotations, and then date again in a quotation. Can we do just a double quote at the
In
start, ISO date, bracket open, date, bracket close, and then close that quotations?
Yeah, we can let's do it after the today's session.
Sure. For
So
this also, I'm having some collection object was not callable like that. I'm
no worries, no,
facing.
we'll sort it out. We'll solve it out. Let's
Sure.
or
Yeah.
people will start leaving before like office is there, right? So
Yeah.
basically,
We'll
okay.
go
So
for it. Yeah.
okay, you
Stop
stop.
sharing. Yeah.
I will share, but mine is uh, not sure.
Ashish, also like I have shifted myself from the evening batch to morning one. So can you share me with your drive link,
Uh,
or the notes are same like the one you had shared in the evening also?
okay, Silpa, right? You were there in
Yes,
evening
yes,
batch.
yes, yes,
Oh, okay. So like I think yours is like two ahead, right? Like this one, like we're starting.
yes. So, right
Is
now
that
evening,
fine?
yeah, that's fine. It will be a revision only because I
Oh,
had
okay.
shift myself to morning and this was the closest one.
Okay. So okay, I'll provide you the link. I the nodes are basically same.
Okay.
Little bit modification if I do it.
Mm.
If anything change, but I think I'll provide you the link drive. This
Okay.
morning link drive.
Okay.
I'll do it. Okay, after the class I'll do it. Is that okay?
Sure.
Yeah. Okay. 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 So where were we yesterday, guys? This one, right? Chi-square,
Yeah.
right?
Chi-square properties.
Chi-square, and this graph plotting was we need to. And one more thing, I think Dinesh, what you are asking, positive and negative skew. I think
Uh-huh.
I didn't explain that correctly, which I felt like I was checking this just before this session. I was checking that positive skew and negative skew.
Uh-huh. Uh-huh.
The quickest way I can like verify that. No, I'm not sure why this laptop is suddenly so slow. Okay, so if you see here, you were talking about that right positive right direction and negative direction,
Yeah.
right? So
Yeah.
I think that is correct. If you see here, this is called positively skewed.
Uh-huh.
Can you see the figure in the right hand side? This
We
one.
do.
And left negative skewed means towards the negative side.
Okay, so left skewed is a negative skewed and right
And
skewed is a positive skewed.
yeah, so the positive direction, if your skewness is there, so this is positive skew, and that also making sense here. If you see chi-squared distributions graph, these are what?
Positive.
Positively skewed. But when it is going for more degree of freedom, like the increasing degree of freedom, it will looks like a normal distribution
Yeah.
that we already saw. Now let's try to understand how I plotted this one. To understand this one, if you see in the x-axis, I have used numpy and this line space function from numpy. Here what I did, this is actually 150 I have given. Now what is this x-axis values using numpy space? So we'll verify this one. Let me connect. Is it not connecting? Okay. So if you see, and again, if you want to know more about it, you know, guys, right? What where to go and what how to find. But here I'll show you what is x. So in the x-axis, I am plotting np dot line space 0 to 150. Okay, so this will generate number evenly spaced. Evenly spaced means um, evenly spaced means if you go to the official documentation, there we'll find the proper answer. If you see here, numpy dot lean space, right? And there is a starting point, there is a stopping point, like from where to where you want to generate the numbers. Okay, and this third parameter, if you see, there is a default value of 50. This means how many points you want to generate. Okay, and if you don't give anything, it will take 50. Okay, so now if I'll run this, can you see what it is generating? From 0 to 150 with 3 spaces. And how many points I'm getting generated? 50, because I have not given anything. This is by default 50, right? Now if you see here, why there is 3 spaces, guys? 0, 3, 6, 9. Why it is
Because
so?
ending is 150 and equally we have to find 50 numbers. So 150
Right,
divided by
right. So guys, did you understand what is happening? So 0 to 150 we have to generate, and total 50 numbers we are generating. That means 150 divided by 50. That's why the space is 3. That is evenly spaced. 0, 3.06, 6.122, 9 point. Okay, if I'll, can you tell me if I'll make this 1000, what will happen?
Ashish, can you please repeat it once again?
So if you, so tell me if I'll make this 1000
Okay.
and I am going to generate 50 numbers, because that is by default value, right? 50 numbers.
Yeah.
And if I am giving it from 0 to 1000, then what will be the evenly spaced number here? 0,
20,
1000 divided by what? 50.
50. Yeah.
That means what?
20 numbers will be there.
20, not 20 numbers, 50 numbers will be there, but the
Okay.
space between each number will be what?
Okay. 20, 20, 40, 60.
40,
Okay.
60, 80, like that. Okay, like that. So
But
here if you
20, 40 is fine. 61, 81, 102, like that it was there, right?
like this is 20 something, 20 point something, right? So when, like, see, 0, then
Okay.
20.4, then
Mm-hmm.
20.4 plus 20.4,
Mm-hmm.
40.8, 40.8 plus 20.4, that will be 61, right? So 20.4 here we're multiplying, sorry, adding, right?
Okay, so we were adding these 20
So
point
consider
plus
this is
40
around
point.
20, right? Around 20. It's not like, so the
Okay,
why
okay.
we're doing this? What is the motive here? That is important, right? Why we're doing this? Why this we are generating this x? To plot in the x-axis. So our aim is to plot this graph. Okay, I'm explaining the code for this graph, how I draw this graph, right? So here this
Sir,
x.
excuse me.
Hmm.
Sir, how it took 20, that interval?
So this is like 20 start point plus end point divided by total number of points.
Sorry, I didn't get, sir. Can you please explain again?
Start point plus
Okay.
end point
Okay.
divided by total number of points that we're generating.
Where is the total number of points?
Here in this documentation, if you don't mention,
Oh, okay.
suppose it is by default 50. Okay, if
Okay,
I
okay.
need more, you have to mention like this. Suppose I need 100 numbers. So what I need to do? Now tell me what will happen to x.
So 0 plus 1000 by 100.
Okay, so 10,
Okay.
20, space will be 20, but here you mention what? How many numbers you want? 100. So
100.
here
Okay.
the x will be hundreds, right?
Okay.
And
Okay.
evenly spaced, evenly spaced. Okay, so like this,
Okay.
like this function works. So my motive is to generate this curve where in the x-axis I'll keep all these numbers. Okay, x numbers in the x-axis. Okay, here in the x-axis. This is for x-axis. Now, what about y-axis? What is there in the y-axis? Now you verify here what I did. this is my y, okay, chi-square distribution I am plotting, right? So this is my y, okay, and here x is, I told you yesterday, right? X1, x2, x3, right? Here in place of x1, x2, x3 I'll put. So that x1, x2, x3 is coming from here, this 50 number. So here actually I just show you, I take 0 to 150, and by default I am giving, right? So x1, x2, x3, x4, like this, okay? Like this, how many we have? X50. So what we are going to do, we are going to put this x1, x2, x50 in this equation, chi-square distribution equation, and we're going to find y. Okay, this is how we are going to do. Then we are going to plot x1, y1, x2, y2. We'll put 1 point and verify the value. Then we'll keep that 1 point and plot it. Like this, we are going to plot it here. But how to do that? We generated the x-axis here. What is, how to generate the y-axis? Y-axis is nothing but this function, this whole mathematical expression. I told you yesterday, right? Like in Python, we do not to vary. We just have the required libraries to input, and it will calculate the mathematical operation for us. So this is the library. If you see here, I'm importing chi-square function here, chi2. The name is in scipy.statistics. The name is chi2. Chi2 means chi-square function. So now this is my whatever mathematics we are discussing here. This is my function. Okay. Now what I told you, we'll take one x1 and we'll put it in this function and calculate the y. The same thing we're going to do, but here one catch here, that is apart from x1, I told you apart from x1 we have another variable here. What is that? What is this k?
Degree
Frequency.
of freedom.
Degree of
Degree
freedom.
of freedom. Yeah.
Okay, so degree of freedom, that means what? Along with changing this x with x1, x2, x3, we need to change the degree of freedom. Then only we'll verify with increasing number of degree of freedom, it is following a normal distribution, isn't it? So if you see, the degree of freedom for this graph is 100, right? So with that means apart from x1, x2, we'll change the degree of freedom. So to keep the degree of freedom, I make a list where I took degree of freedom as 3, 4, 5, 6, and 100. 5 values for the degree of freedom I took in a list. So
Any
that,
numbers?
sorry,
Any number, random numbers for degree of freedom?
yeah, any, like this is for our convenience, that we need to see, like with degree of freedom 3, with degree of freedom 4, you can take degree of freedom 8 also, not a problem. Okay, so this is to show you with increasing number of degree of freedom, the curve is looking like what? A normal distribution. So we are all set. Okay, guys, what does that mean? We have the degree of freedoms, we have the x-axis. Now let's put into the function, chi-square function with these values and plot it. How to do it? Now if you see here, I am running a for loop. This line is to do what? The figure size. Okay, plotting the figure where we are going to draw the curves. Okay, here one for loop to iterate over each degree of freedom. So for degree of freedom in df, so df means this list. Making sense, this one? Now that means for degree of freedom 3, you perform these 2 lines. Then from degree of freedom 4, you perform this 2 lines. Degree of freedom 5, you perform like that. Okay, so if you see here, first loop, y equal to chi, so I'm calling this chi-square dot pdf. That means the pdf function of this. So see how I'm calling that mathematics here. This whole equation I am calling, or I am executing by calling what? chi2 dot pdf. Okay, here chi2 and pdf function, this function takes how many arguments here? X and k. And we have all these things. X we have line spaced numbers, K also we have in the list, right? So here that means for this X and degree of freedom 3, this is the first iteration. Calculate Y. Now tell me what is Y, the D type of Y? What is the data type of Y?
Array.
Everyone agrees with that? Array or not? Or a single point? So in every iteration, tell me what is the data type of Y, and if it is a iterable, then what is the length of Y? Try to think.
Y is
This
50.
iteration Y will be an array of like whatever is the length of X.
Right. So guys, are you following? So whatever is length of X, I am passing that to the chi-square function. That means I am passing each point x1, x2, x3. How many I have? X50. 50 numbers I have, right? Each number I am passing this in this equation and calculating the respective Y value. Now that is Y. To verify that, let's do one thing to verify this. I will.
We'll have 3 X values, right?
Sorry, 3.
X. We have 3 values in X, right? 0
We
to
have,
150 and 50
no,
interval.
this is my X. This is my X. And these are the 50 points in X axis.
Okay.
Guys, are you getting any query here? This is my X. So every point I am like, when I pass this X to this chi-square.pdf function, what is happening? It is calculating all the Y, right? So let me print what? Y. Okay. Then it is going to run for all the loops. Let it run for one loop. Right. So this is my Y. For degree of freedom 3, I break the loop. Okay, I break the loop after first iteration. So it is only getting calculated for degree of freedom 3. Are you getting what is happening here? This for loop, this Y value, when I put X inside the chi-square function, chi-square.pdf function, X and the degree of freedom. In the first iteration, degree of freedom is 3.
So for a better understanding, I'm asking like Y is in the chi-square formula. We are putting the X values like with the length space we got 50 values, right? So
correct.
with that 50 values, I mean with the 50 points, we were calculating the Y value with the
Respective Y
degree of
value.
freedom. Okay, so with the degree of freedom 3, right?
Correct. So now what I'm going to do, I'm going to plot these points. I have X, I have Y now, right? Every X1, Y1, X2, Y2, I'm going to plot it. That's what I'm doing here in this line. Okay, shall I remove this break and print, guys? Did you understand now? Now this will happen for all the degree of freedoms. So for every degree of freedom, you will generate 50 number of Ys. The X will be same, right? And I'm going to plot it here in X and Y. Now X 50 points, Y 50 points, and the degree of freedom is 3. In the next iteration, degree of freedom will be 4. Same thing again will be calculated, and I'm going to plot it. Okay, this function means you have to plot the naming legend, right? That means the labeling and all. We'll see. So this is what it looks like. Okay, like for every degree of freedom, you are plotting one curve in the same graph. In the same graph, you are plotting for every degree of freedom, and this plot dot legend and all. Because of this, you are seeing this things. Okay, so if I will remove this and rerun this, can you see what is the difference here? If I remove this plot dot legend, then what happened? The labeling thing that were the annotations, you can say, right? If you see the annotations here. Okay, And x-axis, this x label means the name you want to give your x-axis. If I want to give it as what, x-axis, probability density, y-axis, like this. So what will happen if I do this? Okay, the name of x-axis and y-axis. We'll also cover in detail in the visualization chapter. Okay, guys. So this is how you draw the PDF of chi-square distribution with different degree of freedom. Any query?
Ashish,
Hmm.
like not below to that, like about to that legend line.
Yeah.
Yeah,
This one.
plt dot plot x comma y, then label equal to f.
Huh. Huh. So we'll also cover this in detail. Okay, this function PLT. So PLT is coming from here, guys.
Plot. What is that?
Matplotlib.
Yeah,
Matplotlib.
matplotlib. Yeah.
Matplotlib.pyplot. Okay, so this is a big name, but yeah, so you will get acquainted with this. Okay, even if you write like this, import matplot, but just this all, and matplotlib.
Lib. Yeah.
See here in the fourth option, they're already providing you matplotlib.pyplot as PLT.
But Ashish, like even if we were only were importing matplotlib as PLT also, it will work, right? Because in that it is having this. But to reduce the execution time, we were telling the
So
system
pyplot
go.
also you need to, so from matplotlib, you
Uh,
have to uh, uh, borrow this also, pyplot. So if you
but
write
however,
like
in
this,
this matplot library only, this thing was there, right?
so this is the same concept as what, class and object. Okay, so these are
Okay.
the classes, we are calling the objects or functions from that classes, like with this dot. Okay, so when we say matplotlib dot any function, what does that mean? That means from that class we are, or from that object we are calling that function. So this
Okay.
import statement we have seen, right? So this import means what? Modules means what? Combination of classes, functions, methods. Okay, we are borrowing that, and as per the requirement, we are calling the respective function. Like we are what we did from, so SkyPy is a class which contains all the classes,
Mm-hmm.
methods. Stars also one type of methods, object. Okay, from stars also we are importing another function called what? Chi2.
I too. Okay.
And this chi2 function defines with some arguments, keyword arguments. Okay, and from here we call another function that is called what? Dot pdf. Right here we call it chi.pdf.
Yeah.
So this is the beauty of object oriented programming. Like you can create object and you can utilize that object later by calling that object. So this is the example of what? Oops concept, object oriented programming.
Yeah.
Okay, so now this part clear, Dinesh? You
Yeah.
asked
Yeah.
me.
Yeah.
So
Fine.
this matplotlib plot function will take how many necessary parameters? Two. One is the
Okay.
x-axis points, y-axis point. So this is nothing but what? X1, y1, x2, y2, like this it is taking
Mm-hmm.
and plotting. And this labels means this one. After plotting the curves, label means this one, because we have multiple curves here, right? 6 curves.
Yeah.
How to distinguish? So matplotlib created different colors for each curve, and it returned the respective value. That means the blue, for the blue curve here in this graph, the degree of freedom is 3. For
Mm-hmm.
the yellow curve, like that. So this is the explanation of this line.
Label F.
And this one, what is this one, guys? String formatting, print option. You forgot? Let me remind you. So print,
Formatting, right?
my name is, you remember
Yeah, format.
how to write this in a string formatting method? Same thing,
Yeah,
same thing,
we write F in the front.
right? So what will happen here?
F.
And what is other changes?
We can delete that. Yeah, and the name is, yeah.
I think here also will get error because what?
Yeah.
Same thing we're doing here, guys. df equal to, then curly braces the df. This df is coming from where? This iteration. Because for each degree of freedom, we are plotting it, right?
Mm-hmm.
So this plot clear?
Yeah. So we were using the legend function. So because of that, like we were giving the label. If we are not using it, then we don't need to give it, right?
Yeah. But if you don't use it, how will you distinguish between the curves? You have to
Okay.
give it,
Okay.
right?
Okay.
How to know like this one is for degree of freedom 100, this one is for degree
Mm-hmm.
of freedom 8. So the point is here, if you see, when I keep increasing the degree of freedom,
Mm-hmm.
it is like taking. So guys, that goodness of fit test, right? You remember yesterday I was saying.
Yes.
So chi-square distribution also can be used to do this, because it allows us to compare the observed frequency of a sample of data to the expected frequency of a certain distribution. That means what? That means you have the data and you don't know the distribution, but you are expecting this distribution may be similar to normal distribution or exponential distribution. Okay, so to verify that quickly, what you can do, you can utilize this goodness of fit test and verify whether your expectation is correct or not, whether your data is following the distribution that you are expecting or not. Okay, so for example, let's say we have a sample of data with n observation. That means what? How many points are there? N observations are there. We want to determine whether it's normally distributed or not. To do this, we can first divide the data into k bins. So what is bin concept? We have seen this bins concept anywhere. So that means, okay, let me tell you the bin concept here. Suppose you have these points in the x-axis, okay? These points 1 to 100, suppose 1 to 100. Now, for each point, let's see what is the frequency or probability. Okay, we are doing it. Then we are plotting it. For each point in the x-axis, we are calculating y, what is the frequency or PDF, and then we join it and plot it. So Bean's concept means divide this 1 to 100 into beans of some interval. Suppose I took 10 numbers and I make one bean. So this is my one bean. Another 10, one bean. Another 10, one bean. Like that, how many beans I will have here? 10 beans. So after dividing this 1 to 100 into 10 beans, every beans frequency I will calculate. Okay, or like without considering individual point, we'll now consider the beans frequency. Then how many beans frequency we'll calculate here, or we'll draw here 10 beans, because we divided this into 10 beans. Why we need to use this concept, guys? Any thought? Instead of going for point to point, why we like we create beans and then calculate the frequency? What is the benefit?
I think to make it quicker.
Reduce the time.
Okay, okay. So
We
Because
can.
in bin concept, we can take more than 1 point. So multiple points will be taken. So
correct. You are close. You are close. Correct. Correct. So consider you are having lots of overlapping points. That means suppose here is 1.2, 2.0 and 2.1. Both frequency are same. Like suppose this is 90 times occurring, this is 89 times occurring. So kind of similar. Okay, like kind of overlapping frequencies. So overlapping frequencies means like if you will group them together, this will act as one type of frequency and your visualization will be smooth here, rather than having an overlapping points on top of one another. So the way of interpretation, way of visualization will be easier for you. Okay, let's go back to our what we're discussing. Divide into k beans. Each beans represent a certain range of values. We can then calculate the observed frequency on each bean, which is the number of observation in that particular bean. Next, we can calculate the expected frequency of each bean under the assumption that the data is normally distributed. We can do this using normal distribution probability density function and the mean and standard deviation of the data.
Sir, like
And
what is the frequency here? Is that
so,
probability?
not probability. Here I'm referring as frequency, but frequency means like how many times. Suppose 1 to 100 we have, right? So suppose this is the age. Then at 25, how many people are there? Suppose in the y-axis you have what number of people is having that particular age. So in 25, I have 10 people. So what is my y value here? So this is be 25, 10, this point. So this frequency means what? 10 number people is having that particular age. 30, then you will go for 30. 30, how many people are under 30, like not under, at 30, at their 30. So that the number of times it is occurring, this 30. So here if you consider this 30 number, how many times it is occurring in your data set?
Okay.
That is your frequency. Okay, now here, if you see, finally, we can use this formula. Okay, let me scroll down so that you can verify properly. So this is my formula to do the test. What is the formula? Can you try to identify what is the formula? What is OI here? It is the observed frequency. It is the expected frequency, EI. EI means that you are expecting this to be normally distributed. So you test it by saying your frequency and the frequency that you expecting, you subtract it and give the square. Now what will this happen? If this value will be small, what does that mean? That means this difference is small. If my observed frequency data and my expected frequency data, both difference is small, that means what? They are close to each other. And if this difference is large, observed frequency difference and expectation frequency is large, then what that means? This value is large. That means what? This distribution and this distribution are both different, not similar. For quickest example here, I have created one small example here to understand. If you see your observed, this is your observed data. Suppose this is your observed data. These are your x1, x2, x3. Let's forget
observed
about
data means that bin you're saying, right?
no. Forget about the bean one here. This is a small example. So let's consider you are not creating the beans. You are just going for the direct numbers. Okay, this is my observed data, means the data you have, the data you have been provided with. Expected means the data from a normal distribution. So if you see here in the second point, calculate the expected frequency of each bean. So here I'm not taking the bean so that it will be easier for you. Each data point, you consider each data point under the assumption that the data is normally distributed. What does this mean? That means you have the expected data with you that is normally distributed. Suppose this is my expected data. Somehow I captured some data from a normal distribution, although it is not normal, but just think like, okay, forget about normal distribution. You said this is my expected data. I don't know which data set or which distribution it is following. This is my expected data. This is the data I have currently. Whether this two data, that what is I'm expecting or what is I currently have, whether these two data are similar, following similar distribution or not. How to know that? Using this good fit test. If you see here, statistical module called starts function, okay, starts. There you can call what? Chi-square. So for this, so to understand this word, if you will hover around it, I think it is showing you the explanation. Calculate a one-way chi-square test. This function is used to do what? Calculating a one-way chi-square test. And if you see the parameters, are you able to see the screen? Or shall I zoom this part, the parameters part of this function? What is the parameter?
F observation.
FOBs.
F ops and F expectations. What are these datas? Array like structure. Okay, two parameters, observed data. So the order also should be same, right, guys? If I change the order, will there be any difference?
Yes.
So will it be impacted if you change the order?
Yes.
Look at the mathematical formula here. Yes, math.
The
What is it,
numerator
Ashish?
will not change, but the denominator we are taking only the expected frequency.
So always the expected frequency. So see guys, this is the mathematical formula, and this mathematical formula is been already implemented in this function. Okay, in this function you just need to pass two parameters. That's your job. One is observed data, one is expected data. If I'll change the order, maybe the numerator won't change, but the second, whatever second parameter we are passing, that is considered as our expected data, right? And that will be divided at the last. So the changing the order will impact your decision, right? So make sure first parameter is what? This is according to what? The documentation of starts dot chi-square. Okay, first parameter is observed, then the expected. Now once you pass this, this function is returning two value. How did I know this function returns two value, guys? See, this is a function, calculate a one-way chi-square test, right? These are the parameters. Okay, and this function returns how many values? Two value. One is a p value. What is p value and all? We'll see in few minutes. Okay, when we'll go to the hypothesis testing. And one is the chi-square test statistics. So if you see here, I am capturing this two value, chi-square test statistics and p value with this variable name by calling this function and passing this two parameter. Now I am printing this both the value, chi-square test statistics is 5 and p value is 0.5. Now can you say something by looking into this? Now let's make the expected data totally opposite. That means what? Every point I will make what? Negative. So I think I have to run this in a different cell so that you can distinguish the result here. Now can you see with this chi-square test statistics and this chi-square test statistics, what is the difference? Now the chi-square test statistic is, so now this is the data I have, this is the data I am expecting. And here if you see, more the difference here, more the data is not similar to both of them. So these two data are not similar, that you are without using this formula you are getting it, right guys? Your observed data and your expectation data is totally kind of opposite. Making sense, right?
Because of the negative values you're saying.
So this is totally different, right? Now, if you see, when I knowingly passing these two different values in this chi-square statistics, what I'm getting? A higher value of test statistics that also negative, and the p-value is also 1. That means what? The more the test statistic or the more the p-value, the data will be different, totally different. The less value you will get as test statistics in this case. In this case, here I ran it for what? Without non-negative numbers, isn't it? So here you can see this is a bit of similar to each other because I am getting 5 point something as my chi-square test statistics. But here I am getting what? 241. That also with a negative sign. That means totally opposite.
The
And
p-values, excuse me, sir, the p-value is the similarity of the, or somewhat.
No. P-value means something in statistics that I'll come to that point. Okay. So p-value is that holds some other meaning in statistics. So let's not discuss here because we have a whole dedicated, this one on p-value. I'll come to this part. So test statistics you consider here. Test statistics small means both the distributions are similar. Test statistics larger means both the distribution are not similar. Now suppose you have a normal distributions of 1 million of data and you observed from your work environment you got 1 million data. Whether your 1 million data is following normal distribution that you currently have that is similar to that database, data set or not. How to verify? Quickly do one chi-square test, goodness of fit test. If we'll get less value or lower value of test statistics, that means what? Both your data are quite similar distributed. If you get more number of test statistics, so these are the advanced statistical techniques to verify your data quickly, whether it is following any particular distribution or not. Okay.
So how can we know that, like, if we get the result in negative, then it is
no larger. I said larger.
Okay, so if we get larger amount of number in a result, then it will be in
So this is also making sense, guys.
Normal distribution.
Two numbers are similar, close to each other. How we are knowing this? By subtracting this one from another. If the difference is larger, so OI minus XI is larger. That means OI and 10 minus 5 and 10 minus 2. Which one is closer to 10? 10 minus 5, 10 minus 2. Which one is closer to 10? 5. And how we are verifying this? 10 minus 5 is 5. 10 minus 2 is 8.
Yeah.
The larger the value, the more the difference is, isn't it? So if two distributions are similar or not, if their difference is small, that means they are similar or close to each other, isn't it? Yes. This is what it is happening. So that means what? You also need not to memorize that, okay, this is higher or this is lower, then we need to think. From the mathematics, you can understand. That's why we are learning this. Okay, if the difference is large, then both the distributions are not similar.
Okay.
Okay. Now,
sorry, sir. One question. So the data we have taken, this observed data and expected data, so it is not a float number, right? So it is not continuous distribution then?
No. Like just for example, I told you, right? Continuous distributions means what? You're like not always you need to have that float number. That graph should not be stopped anywhere. So this also you can make continuous plot. Good question actually. So here in the observed data, 8, 6, 10, 6, 8, then what is that? I completely ruined it. 6, 7, 8, 9, 10, like this, right? So here that doesn't mean like we are only considering 6 and 7. We are not writing 6.1, 6.2 like this here, but it is there. So continuous means the data should not, this plot should not be broken anywhere. It should be continuous. That means you have at 6 also you have some values, at 6.1 also you have some values, 6.2 also you have some values. So that doesn't mean like I have not, it is not continuous because I didn't write 6.1, 6.2 till 6.9, right? The continuous means no breaking of the plot. Just to make you understand, I took this a few numbers.
Okay, sir. So to generate this data, we can use that NumPy library also.
So random number also you can, good guys, good. You can create your own data, and that line space function I told you to generate line space. You can create that data, and you can create another data from what? Normal distribution. How to create normal distribution? So you yesterday, right? Random dot normal, right?
Yes, sir.
Random dot normal
Yes.
from 0 to 1. You create few numbers from there. You create few numbers from line space. Then you do this test and see whether that is equal or not. Okay.
Okay, sir.
So let's go to the next thing what we have. Point and interval estimator. Yeah, so this one, okay, I was talking about the jet table, t table, guys. Okay, so what do we mean by point estimation? What do we mean by interval estimation? Interval estimation. So in statistics, I'll try to read it out. A point estimate is a single value that is used to estimate a population parameter. Single value in the sense what? I'm calculating the mean of population data. Mean population will be around 5.3. That's what I'm saying here. For example, 5.3. So here when I say 5.3, I am pointing out a exact point or exact number, 5.3. And standard deviation is 2.2. So when I am saying standard deviation is 2.2, I'm pointing out to an exact number. This is called point estimation. When you are pointing out to an exact number. Then what is interval estimation? So when I'm saying the population mean will be between 3 to 5. I'm not sure what is the exact value, but somewhere between 3 to 5 population mean. Similarly, I'm saying population standard deviation will be 1 to 3. So here what I am giving, instead of a point, specified point, I am giving what? An interval. So this interval will give us more confidence because sometimes we are not sure what is the exact value because population data is too huge, right? You can't. So better to say an interval value because the population data will, the population mean will be falling between this to this range in this interval. This is called interval estimation. Now in the interval estimation, we have another type that is called confidence interval estimation. What is the confidence interval estimation? Confidence interval estimation means you are going to give a probabilistic score to your estimation. That means suppose you are saying population mean is falling between this range to this range with certain amount of probability. That means 9.95. Suppose, for example, I'm saying my population mean will be between 3 to 5 with probability to score 0.95. What does that mean? That means I am 95% sure. Or I will try this experiment 100 times, and out of 100 times, 95 times the population mean will fall between 3 to 5 interval. Are you getting? Making sense, right? So confidence interval means what? With some amount of confidence level or confidence percentage, you are going to say what? This is the interval where your point is going to fall. Okay, so this is about point interval estimators and confidence interval estimators. Any query here? So if you see this figure here, what I just described, am I audible, right, guys? Any disconnection happened?
Yeah, Ashish, you are audible.
Okay. So that happened in like sometimes back. I was keep talking, and after 10 minutes, I realized that I got this like total the Zoom got crashed. Okay. So here, if you see what I just described, if I'll tell you that I am 95% sure my mean will be falling between which region? This to this. That means what? I am 5% sure my mean will fall into this two red region, isn't it? That in the other way I can say like that. I'm 5% sure that this mean will fall in this region that I highlighted. But I am 95% sure the mean will fall in this green, this line, this range to this range. This is the confidence level of interval that I am specifying.
Sir, sorry.
So
So mean will be an exact value, no? So will it fall in the under a particular range? Only the standard deviation will be between the ranges, right?
So good question. So when we take samples, okay, can you imagine when you take a sample every time? So we saw CLT yesterday. What we did, we took some samples, right? There we're calculating the mean, which will be nearly equal to the population mean.
Yes, sir.
Now that mean, if you will take different samples, different time, will that be exactly same mean you are getting every time? No, right?
Okay, so you're
Because
saying if the samples are more, you'll get different means.
correct. And so that's why I'm saying it will be around here somewhere, this range to this range, not beyond this range, and that also I'm 95. If we'll carry it out that CLT one, okay, 100 times. 100 times you will repeat that thing, and 100 times you will get the means. That 100 times out of 95 times out of that 100 times, the mean will fall in this range. Whether it is here or bit here or bit here or here. Are you getting it?
Yes, sir.
So that means population means we are calculating based on samples, and we are taking different samples and different time. So that will be not exact point here. Point will be vary towards left and right bit. And to give that statement, to understand, to make anyone understand, we are saying like 95.95 is my probabilistic score that I'm saying if I'll calculate the mean, this will fall between this range to this range. That's what I'm saying. Okay, so but how to calculate this confidence interval? So again, you have to learn the statistical methods to calculate the confidence interval of something. So as I told you, these are the advanced statistical method to calculate something, and this is not all. If we'll try to explore, you will get so many statistical methods. And when we use confidence, and here did I miss anything? Your desired confidence level is usually, so this alpha and p value, you need not to worry, guys. This alpha and p value we'll see in the hypothesis testing in our next few minutes. Okay, don't worry. I'll tell you what this alpha and what is the p value is. When do you use confidence interval? Population means, estimation of variations. So if someone will ask you, what is the mean value? What is the average age of this population data I have for the whole 2-3 states or country? So there you can't give them, if you are considering a population data, you can't say this is the exact mean, because the mean can vary at any time. And population data is so vast also. So population mean, their standard deviation, for each of these statistical value, you can use confidence interval to say something without saying this will be the mean. 5.3 is the mean. Without saying that, you will say like what? The mean will be from 5 to 6 interval with 96 or 90% of So that percentage of confidence will come from this alpha, guys. Okay. And this alpha value is been need to be chosen by the domain expert, because if you suppose you are exploring this data in a banking sector, there the alpha value will be different. If you are exploring the same concept in a healthcare sector, there the alpha value will be different. Now those alpha values will need to be explained by or defined by, like, which part you want to ignore, how many part, 5% you want to ignore, that suggestion needs to come from an expert. Okay, we'll discuss this.
Ashish, like you said that population mean, right? So you said an example of you have given. Let me let me take an example of, like, I've been given 3 states. So if I need to calculate the population mean for these 3 states, I'll get 3 means, right?
No. Consider the whole country as population data, not 3 states. Population data is my whole country's age data.
Okay, so
Now I
that time
want to
I'll
know.
get, that time I won't get if I'm calculating for the whole country means, like, I'll get 1 mean, right?
How come? That's why we can't do that. That's why we learned this CLT and all, right? Why did we do sampling and all? Because we need not to calculate the population data, and that is also not feasible. You are calculating the whole average age of country. How to calculate that? We can't collect the data also from everywhere, right? That is also one challenge. Even if we collect all the data, all the people's data, to calculate the mean by summating, this will take days, months, right? So what we
that
did?
also will be incorrect because
So what we did? We took samples. Let's take a sample of cities of few states.
Okay.
And calculate the mean from their samples. The CLT one, if you remember.
Right? Okay, so for a whole country, like, I'm taking 2 or 3 states. Correct. Or 3.
Correct. Now, if I'll calculate this for out of 30 states we have, right? I'm not sure. 30, right, guys? Okay, so let's, like, 30 states we have, right? Out of them, we tried with 5 states. Then again, next day we tried with another 5 states. There, the mean value will be different, right? It is not a constant. Like, so that's why we are taking help of an interval here. Instead of saying this will be the exact country's mean value, we'll say country's age mean value will fall between this value to this value with some confidence.
Okay, so likewise, you're saying first day I'm calculating for 5 states, and then the second day, likewise, I'm doing it for 3 or 4 days, and with that mean values, I'm doing
so
this.
That mean values
confidence
will be different, right? It will not same exact value, so it will be different.
So with that mean values, I'm calculating the intervals, and then I'm giving the the confidence level stuff, and then I'm giving them the average ages between these two.
Kind of. Your understanding is kind of correct, but how to calculate the confidence interval? That is what we are seeing here. Okay. So as you said, 5, then we'll calculate the mean. This is how you need to calculate a confidence interval. So first step to calculate a confidence interval, first you decide for which parameter you are calculating it. That means whether for mean or for standard deviation or for any other parameter. Most of the frequent choice is what? Mean, right? So first you decide whether for mean or any other parameter you are calculating the confidence interval for. So suppose, consider you are calculating the confidence interval for mean that we decided. This is the first step. That means population mean. We are calculating the confidence interval for population mean. That is first step. Second step is to the critical values of test statistic. Now this is one statistical term for which I told you yesterday, right? Log table, that log table thing. Same that the other table we have to calculate this critical value that we'll see. Okay. I have also mentioned the steps how to find the critical values. First step, decided we are going to do it for mean, population mean. Second step, we are going to find the critical value by following the below steps that I'm going to explain. Third point is what? If for the population data, you have some samples, okay, calculate the sample standard deviation from there, from the sample itself. So suppose you have 10 numbers of people's age, that is my sample data, or one state of people's age. So take that sample and calculate the standard deviation. That is easy to calculate. NumPy dot standard deviation function you call and pass the sample data inside that. You get your standard deviation. What is the 4 point? The size of the sample. Suppose 10 people's age I took, right? So before calculating a confidence interval, you need to make sure you are aware about this 4 points. Now, among these 4 points, which part is not clear to you? The second part, critical values for the test statistic. Now, how to find the critical value? There are 3 steps to find the critical value. So you need not to worry about, guys. You need not to remember these things, okay? Because what we are discussing here, that is what theoretical part, which is behind the Python code. Okay, so here Python codes are already there to do this stuff. You need not to worry or need to remember this tongue, but you just need to understand what is the flow, how it is being calculated behind the scene.
Yeah, 10 line of words in 2 words.
Correct,
You know.
correct. So how to find the critical value here? So steps, for first step, you choose your alpha. I told you this alpha should be coming from what? A domain expert from your domain as per your data. Because this 1 minus alpha will be the confidence score or percentage. If you are selecting alpha is 0.05, that means what? You need to be 95% sure. 1 minus alpha is what? 0.95. If you are choosing alpha equal to 0.1, what is the confidence percentage? If I choose alpha equal to 0.1, what is 1 minus alpha value here?
99%.
Not 99, 0.9, 90%. Okay, so that's why I asked you. I know. So 0.1 means what? 90%. 0.01 means 99%.
Yeah.
Okay, even sometimes people use alpha value as 0.001. That means what? 99.99. Right, guys? That also people use, but it is best to look at the research papers published in your field or work environment to decide the alpha value. But usually people take this value, 0.05. Okay, that is the first step to do what? So we have 4 steps, right? 3 steps we already know. Second step we are discussing, and the second step is having what? These steps. So when we write 1 line of code in Python, calling the module, these things are getting considered, right? Okay, so here, what is this next action? Decide if you need a 1-tailed interval or 2-tailed interval. What do we mean by 1-tailed interval? So this means between x1 to x2. If this is my interval, this is called 2-tailed. If I say minus infinity to x1, this is my what? 1-tailed, because I am fixing at this position, but I am not sure about this in the negative direction. Similarly, x2 to plus infinity. This is also example of what? 1-tailed. That the interval, how you need to define your interval. Like this with 1 point or 2 points. This is called 1-tailed or 2-tailed interval. But we'll go with this one, okay? 2-tailed interval. This will be easy for us to understand.
Sir, so 1-tailed means it is always like -1 to x1.
That means you are not concerned about the other part, only this part. From this to the rest of the negative part, it will be falling between this range.
So it is like either positive or negative range.
Yeah. So this is also, see, minus infinity to x1. What does this mean? Any number between, suppose this is
Can
my
say
x1.
anything less than x1 or anything greater than x2.
Greater than x. So that means what I'm saying. This means what? Any point in this direction.
Less than x1.
Less than x1. This means what? any point in this direction greater than, so here it is x2, right? Suppose x1, suppose this is x1. Now you got it, right? Here we are
Yes.
defining one point, and the other point is we are saying positive direction or right. So this is one tail, and if you see, I use this square bracket to if there is we are not certain or infinity, but in that is a square bracket. This is how you need to write in mathematics. If this is, you are using this square bracket, that means what? You are sure about that particular point. But just to tell you, because this one tail and two tail concept, we are having this in the table. We'll see it. Okay. So let's go with two tail. Okay. Let's not go with one tail. Let's go with two tail. But that is also one thing you need to consider, which type of interval you are choosing, one tail or two tail. Now, here is one thing you need to keep in mind. There are two tables you can refer, like log table. And this thing we are doing for what, guys? What is our motive? Can anyone help? What is
To
our
calculate the confidence interval.
to calculate the confidence interval? That is our main objective, whole
Yeah.
the top objective. What is the sub objective after that?
To find a critical value.
Right. So this we are doing to find the critical value. Okay. That means in this table, T table and Z table, we are going to find the critical values. And how I will show you. Before that, you need to understand here, if you have your sample size greater than 30, that is approximately normally distributed, your data. That means you took a sample, right? And that sample size, if you are taking N30 greater than 30, and your data is normally distributed, then you are going to use Z distribution. Okay, this is a rule. Okay, I'm not going to the mathematics why they did it, but okay, these are semester chapters. Okay, in statistics. And if your sample size is less than 30 and your distribution is unknown, not and, less than 30 or your distribution is unknown. Did you get what I'm saying here? If your sample size is less than 30 or the distribution is unknown to you, then you are going to use T table. Just two things we need to keep in mind. So if I,
can you please repeat that once again?
so instead of repeating, I'll ask one fundamental question to you. In the both scenario I explained, if I am taking sample size as 50, and I am having an uniform distribution or exponential distribution, which table I'll use?
So my sample space is, however, more than
sample
30,
size.
right? Sorry, sample size is more than 30, right? So I supposed to use the T table, right?
No. Okay, let me. So first point is Z table. If your sample size is greater than 30 and the distribution is what? Normally distribution.
Normally distributed, okay.
Then you are going to use what? Z.
Z, okay.
If your sample size is less than 30 or even if sample size is greater than 30 or you don't know your distribution, unknown distribution, then what you are going to use? T. Okay.
Can you please say that again?
So what you heard you say?
Okay. So for example, if my sample size is 50 and my
yeah.
Okay. Wait a minute. Yeah. So my sample size is 50 and I'm selecting a uniform distribution means. So that time my sample space is greater than 30. But the distribution was not normally distributed. So because of that, I supposed to use T table, right?
Correct. That means you don't know your distribution. But when you know your distribution and your sample size is greater than 30, you can go for Z table.
Okay, so if I know my distribution is normally distributed, then that is fine. If it is
and greater than 30.
okay, and it's supposed to be greater than 30. Okay, so normally distributed. So if
Right.
it is rather than the normal distribution, like it's standard or uniform, then I supposed to use t table. However,
Yeah, so mainly T table is being used when you
Mhm.
don't have you don't know your distribution, and
Okay.
or like not and or you have a small sample size,
Mhm.
whether that is following normal or any kind of distribution. If you have
Okay.
small sample size, you
For
go for
bigger samples, we always use z table.
bigger sample. We always disable that distribution is known. You are
Okay. Okay.
forgetting that part. Okay,
Yeah. Yeah.
one
Okay. Okay.
condition you are keeping in.
Okay.
So when the
Get it. Get it.
distribution
Get
is
it.
not known,
Hmm.
so actually why
But
I'm emphasizing this here
okay.
in
So
your hmm,
what if we, for example, if my sample size is more than 50,
hmm.
and more than 50, and I didn't know the distribution, what my data was following. That
Correct.
time, what can I do? Because in t table, we only can handle the sample size lesser than 30, right?
No. I didn't say only for lesser than 30. I told you
Okay.
unknown distribution also. I said
Okay.
or. That's why I said or less than
Mm-hmm.
30 or the
Okay.
distribution is
Okay.
unknown. So that time if you have higher number of sample size also, you can use T table.
Okay. Okay.
So this is why I'm emphasizing this, because if you see here, interval estimator of mu with unknown sigma. Unknown sigma means what? Unknown distribution of population. This is what we are doing actually. This is what exactly what we are doing. We are calculating the confidence interval of mu, right? We decided in the 4 points, we decided to go for mu with unknown sigma. This unknown sigma means population distribution is not known. Okay, so what we are going to use here is
T.
population distribution is not known, T distribution.
Yeah.
Okay, so I have explained what is T table and J table. Let's not read this out. Okay, these are this is called a student's T table. This is known as standard normal table. So we'll see. Okay, so better what I'll do, T table. So you are not going to do this, okay, guys? This is being taken care by what? Python. So you need not to worry. You just understand what is happening. Right? So whose site is this? I'm not sure. So many T table organizations and all, right? The T calculator. No, not this one. I want the image. Anyone which is having the image, because I want to show you that. So this is how, if you remember our college days log table, right? So I can remember while taking the extra seats and all. No, guys. So images, right? Okay, I didn't take with images. Value. Happening. Got it. But it's still very slow. Okay, guys, can you see my screen now? If you see, this is called a T table. Okay, this is called a T table, but you need not to worry. You have Python library, just call it and pass the parameter, it will calculate. But how this is getting calculated in the background? If you see in this T table, first of all, I told you one tail, two tail, right? You decide which one. So we are going for two tail, right? Two tail. Now, if you see in this direction, let me use the pen. In this direction, not visible. Can you see the red line? But I am not able to see it.
Yes, sir.
Yeah, we can see, but
Okay. It was hiding behind that zoom panel. Okay, so in this direction, what is there? If you see, this is the alpha value. So that means two-tailed alpha value 0.05. This is my alpha value. I told you, right? Usually people take 0.05, but if your domain expert says go for 0.01, then you need to come here. Okay, this is my alpha value. So in this direction for two-tailed alpha value. Now if you see in this direction, what we have, degree of freedom. So this degree of freedom will come from where, guys? How you are going to calculate the degree of freedom? From the sample that you are taking, right? Sample length minus 1. That is my degree of freedom. Right? So suppose the degree of freedom is 9. That means you have 10 elements in your sample. Then what is my t statistics value? Alpha 0.05 and degree of freedom 9. So this is my 2.262. This is how you need to find out if you'll do it manually. And this is what? The critical value from the second step of that 4 steps we are discussing. Okay. So many things got opened. Let me close few of them. Okay. Now let's go back. So you understood, right? What is how to use the T table now? Now let's come back to our formula directly. Once you get your what? Critical value. So guys, let me summarize this for you. These 4 steps we need to know, right? These steps we are looking for the second step. Now we got it from the T table with the samples degree of freedom and alpha value. Now how to calculate the CI? That means confidence interval. To calculate the confidence interval, this is the formula. Very easy one. Very easy one. What is the confidence interval here? Mean of your sample. So X bar means what? Sample mean that you took. T star is the critical value that you found from the T table. And why I'm giving plus and minus? To find the range. So here the confidence interval is for what? Confidence interval is for CI for what? Mean of population. Isn't it? So if you see mu population equal to the interval we are calculating. Mu sample minus T star sigma root over of m. Where this sigma means what? Sample standard deviation. N means what? Sample size. So let me clearly write it. So mu population will be between mu sample minus T star sigma to the power root over of n, comma mu sample plus T star sigma root over of n. This is my confidence interval. So I can say if I have chosen alpha as 0.05, so I can say mean of the population will lie in this interval with 95% of confidence. Now how to write this in code? Let me quickly show you how to write these things in code. And I'm actually really struggling with this Zoom panel. It is coming in my way while writing something. Okay. But you guys can't see that, but I can see this. So guys, let's do with a quick example. Okay. This is my sample. I don't know about my population. This is my sample data. How many points I have? What is the degree of freedom here?
Degree of freedom is 9.
10.
10 minus 1, 9,
Yeah.
right? So this is my sample. Now, in this confidence interval formula, actually what I need to do, guys, what I need to do first, np dot mean. Let me first write the formula here so that it will be. So what is the CI formula? Tell me. CI formula is mu of what? Sample plus minus
minus
t
T star.
statistic, standard deviation of sample divided by root over of sample.
n.
This is my formula, right? Let's see what we are doing here. Okay, this is my sample. I calculate the mean sample here, right? This part, mean sample. How to calculate? Numpy dot mean and pass the sample data. Clear this one? Now if you see, calculate the 95% confidence interval estimate the population data. What does that mean? I am calculating the standard error. The standard error means I am calculating the variable as SE, and here if you see, NP dot standard deviation of sample divided by NP dot square root of length of sample. That means which part in this equation or in this formula? Which part I am calculating? This line.
That,
This
yeah.
part. Mark my circle, okay? This part. This is SE we are calculating. Please try to verify it. How we are calculating standard deviation of sample, NP dot STD function. Then square root of length of the sample, NP dot square root function. Inside that I am passing what? Length of the sample. Making sense? Now, what we did all the drama to go to the T table, then alpha, then degree of freedom, then we saw, we calculate the T statistics. Here you have this library. That's again scipy.stats. You have to import T function. That means that T table, guys. So in order to go to the T table or any paper you have to get. So here you can directly access the T table by writing this import T. T dot ppf function to calculate what? This T star. That is critical value. Okay. So to calculate this critical value, we need to call T dot ppf function. Now this function will, if you remember in T table, how we are finding it? With alpha and degree of freedom. Here we need to pass that value. There we are manually selecting, okay, 0.95, then not 95. There alpha means 0.05. Here what we are passing here? 1 minus alpha. Are you getting what is the first parameter here? 1 minus alpha. And what is the second? So this parameter is 1 minus alpha. What is this parameter?
Degree of freedom.
Degree of
How
freedom.
come 1 minus alpha, Ashish? Can you please,
So alpha was there in our T table. What is the alpha value?
Yeah, we have a different alpha
Yeah,
value
but what we
suggested.
chose? What we chose?
0.95. Usually you said like most of the people will choose that.
0.05 alpha value we choose.
Yeah, yeah.
0.05 alpha value. That means we are, how much percentage surety we are dealing here? 1 minus alpha percentage. When I say confidence, confidence is 1 minus alpha always, right? Isn't it? Like when I say 0.05, that means what? I am 95% confident.
Yeah.
Confident, right? So here alpha, if alpha is 0.05, then 1 minus alpha is what? 0.95.
Yeah, okay.
And to know more about this function, what you, if I'll remove this, actually you can go through the document or this equation will.
People that saw, we had 2 tail and 1 tail.
So to understand this, what to use 2 tail and 1 tail, you have to go to this T dot ppf. Can you guys go to T dot ppf? Okay, we'll go to this documentation. Okay, because I don't want to erase this part, or we will again I have to write. We'll go to this ppf T dot ppf documentation. Okay, to understand this. So, but as of now, you understand this is first parameter is what? The percentage that your surety percentage. Second parameter is what? The degree of freedom. Okay, we'll see this documentation. Know this. So this value is what? This T star. Whatever value we are getting it T VAL, right? That means what? T star. Now, if you see here, I am calculating this interval because this plus this minus this. This is my interval. So interval variable I am creating here, which is be my this value into the standard error. That means what? This part. This is what I'm calling as my interval, which is what? T star into the term that I circled, which is what? Standard error. So standard error is the part I circled. T star I got from the T table. Okay, interval I am calculating this square T into standard error. Any query to understand this? Now, how to calculate the confidence interval now? You have mu, you have this term. What is the interval? Mu plus this term, comma, mu minus this term. So what is my interval here? So in the left hand side, what I'm keeping? Point estimation, that is mu sample minus the interval, comma, point estimation plus the interval. So now what I can say, the population mean from where I got the sample is falling between this interval. It will fall between 3.83 to 7.16 with 95% of confidence.
So the T star value is will be added and subtracted at the same time.
Not only T star into that sigma divided by root over of n.
Okay.
So not only T star, this whatever inside the square.
Okay. So with the sample with the mu of sample, we supposed to add and subtract.
Correct.
So that we can get the sample. I mean the average.
Correct.
Okay.
So that means what we are saying here, if I don't know my population, but I know my sample mean is somewhere here, then my population mean will fall something from here to here. This value is mu minus T star sigma sample divided by root n. This is mu plus this thing. This is mu minus this thing. This is mu plus this thing. So here we are defining one interval based on the sample that you have. And we are saying we are 95% sure that the population mean will fall in this interval. That means here in our case, what is the interval? So this value is 3.834. This value is what? 7.165. So we are saying the population mean we are 95% sure that the population mean will fall between 3.8 to 7.1. So even if you don't have the whole country's data, you have sample, you can say, okay, maybe the average age of people, that's why we are giving confidence also, because there is also 5% chance that the mean will not fall in this interval. The way of interpreting is different, guys. It's a data driven decision. If you are not sure, you can say to people like this so that they will understand, okay, maybe it will 95% of chance that the mean of population will fall in this interval. This is how you need to calculate the CI. Now that documentation we have to see, right? What is that? T dot PPF. Yeah, any questions?
Yeah, can you take 0.01, 99% in that to see the difference?
Okay.
Yeah.
0.99, right? Okay, let's do one thing, or else I will forget the value that we are getting. Let's see what is the good question. I have not tried that. 0.99. 2.93 to 8 point. Can you see what is happening with your increasing confidence percentage? This interval is also increasing, and that is also making sense, right? If I have to choose a number 0 to 100, that I am not like, so choose a number between 0 to 100 and choose a number between 0 to 10. Which one will be easier for you? Give the confidence. The larger interval, right? So if you say 0.99 here, that means what? Your interval is more here. If you see now I can say I am 99% sure the mean will fall in this region. Because if you see, the interval is now got increased 2.9 to 8.06. Here it was 3.8 to 7.16. Okay, so we are seeing that what? T dot
T.ppf.
ppf. Let's see. Let's see what result we are. What happened? How to use it? Okay, Stack Overflow, people have already given this answer. So in Stack Overflow, actually, like when I started, Stack Overflow is like my, place where I'm getting more knowledge, because there people discuss those things, no? So here, what is the documentation, guys? A student's T continuous random variable for the non-central T distribution. Okay, what is? I have not explored actually, but here the probability density function is f of xp. Okay, where x is the real number. Do we have any functions? Guys, T dot ppf we are choosing, right? What we are seeing? Oh, no, not this one. T dot ppf. How many we have here? T dot, guys, T dot ppf functionality is, where is it? I can't see it. I can see it here, but here also it is taking something. Guys, try to find out. Oh, okay, here. A Q. So these are the methods which take this ppf method takes Q, df, then location, then scale. This is, I think, the mean and the standard deviation you are looking for. Q means what? Percent point function. Okay, try to explore this, guys, on your own once. Let's not waste time now. P.ppf documentation. I'm not able to find it. Do we have in the discussion of the Stack Overflow? I think there people, use very simple language to explain. Nowadays, Stack Overflow is not that much popular because of that Chat GPT. People,
Yeah.
and you have some scores also. If you try to help solve the query in Stack Overflow, that was being considered in the interviews or screening procedure, that what is the score or how many query you have solved in the real life for the people. But after the Chat GPT, people started to pasting the answers from Chat GPT, so they stopped it. Okay, but previously it was there. See, guys, here someone written very clearly according to the reference docs. Here also you will get the reference document. Are we referencing this one? Okay, this one, particularly this one. Here, like, according to the reference docs, the arguments of TPPF are Q, DF, location, and scale. The DF argument is the degree of freedom, which is usually the sample size -1 for a single population sampling problem. Since PPF calculates the inverse cumulative distribution function, by definition, a result of X for a given Q value and DF, there is a probability Q of getting outcomes less than or equal to X for a T distribution with given location and scale, mean and standard deviation. So this location and scale parameter means what, guys? Mean and standard deviation. The arguments are optional and default to 0 and 1 respectively for location and scale. So this Q, 95% margin of error, you want 5% of probability to be detail of the visualization. This is usually done symmetrically. So you have to use Q values as 0.025 or 0.975. What was our question we're looking for? Why we can
yeah. Actually, I've asked like why
have a
we.
one tail or two tail, like in the T table we have two sections.
Okay, okay,
Alpha
okay.
value,
Yeah.
Okay,
quantity,
this
degree of
always happens when you're trying to find the answer, and once you find it, then you forget the question. What was there?
Yeah.
Okay, so I think any tail information is here. No, right?
No, I've actually asked like why we use 0.95 there. Then you said that okay, so we chose the
No,
confidence.
that answer is here, right? That answer is here. If you
Yeah,
see
yeah,
here
that's
to
what.
get, yeah, this is here. But what Silpa said, no, I think that two-tailed and one-tailed implementation not inside this function, because I can't see anything mentioned two-tailed. Maybe because they are getting it as two-tailed only. Not, they have not implemented this function for one-tailed. If I'm not wrong here, because there is no, even if the documentation also you can find there is no mention of two-tailed, right? Like from here, PPF, just a QDF, then this is the mean and this is the standard deviation. 4 parameters it is passing. No parameter for what? That two-tailed and one-tailed. Maybe we have some other Python libraries apart from SkyPy that you need to explore, who will take the one-tail or T-tail. But as of now, there is no such concepts of one-tail and two-tail here. But that's why we are learning this, right? Even if you don't know, you can do it in manually by going to what? This table. Okay, okay. So let's do that part. Okay, so this is finish actually, and we took 2 sessions to finish this one, guys. And we have some interesting topic here. I think this week and only we are going to complete it. I'm not sure, but I think this week will take, right? What is tomorrow? Thursday, right? Only one day we have. Okay. So guys, here one interval and 2 interval estimators that we saw. Okay, point interval and what? Confidence interval. There is another type of estimation techniques that is called MLE. That is what called maximum likelihood estimation. Here I need your patience, guys, to understand few of the mathematics here. Okay, don't worry, you need not to remember or do this mathematics. Just one second. So what we mean by MLE? Okay, without any, let me see how you can. So these are estimates of the parameters of a statistical model that makes the observed data most likely. Okay, they can be used to estimate the unknown parameter of the distribution. When I say unknown parameter means what, guys, of a distribution? Mu, sigma, mean, standard deviation, right? Those are the parameters we are looking for here. And the 3 that you are going to see, 2 we have already seen, 1 is going to see now. Point and interval estimators. They have their respective advantages and disadvantages. Which one will use depend on the goal of analysis, right? So maximum likelihood estimation, and we are going to do this for a normal distribution. Now can you tell me what is this equation? What is whose PDF is this? Let me, whose PDF equation is this? Which distribution? Exponential something, right? Which was there in normal, isn't it, guys? Normal distribution. So this is the equation for what? Normal distribution. because this exponential term was there in the, do I need to go back, or you understood, right? This is the mathematical expression for normal distribution. Let's say we have a sample of n observations and we want to estimate the parameters of a normal distributions with unknown mean and unknown standard deviation. We don't know, but we know the distribution is following what? Normal distribution. Now, how to calculate the mean and standard deviation here? So by understanding this concept, you can now understand how this mean and standard deviation formula got. So standard deviation formula is root over of what? Summation of xi minus mu. This was standard deviation formula. Now, how this formula also derived, you will understood from this MLE, because this is how you need to calculate the maximum likelihood of something. So here, bit of mathematical knowledge I am expecting from you guys. Do you know the concept of derivative? Dx divided by dy, dx dy. Have you seen these terms before?
Yes.
Do you know what is a partial derivative means? So here, these few concepts I need from you to make this understand. Partial derivative means what? Now suppose if you are doing derivative with respect to y, and in the y you have two parameters, okay, p and q. You do the derivative first with p, then by keeping q constant. Derivative of a constant is what? Derivative of 5 with respect to dy is what? 0. So these are, predefined knowledge. If you don't have it, please don't worry, because this is, you're not going to implement this. You just need to understand how this is working. Okay, so I don't want to explain you the derivative concepts again. So first of all, let's try to understand what we're doing here. This is my PDF. This is what I'm doing. I have told you this symbol, right? This symbol and this symbol. What is this symbol? And what is this
For
symbol?
multiplication, this is for summation.
Right. So can you see this symbol is I use? That means this is a multiplication. And what is the multiplication? Here, if you understand here in this, I only know that my data is following a normal distribution. I don't know mu, I don't know sigma, I don't know anything. So how many unknown variable I have in this equation? If you see, how many unknown variable? If I have my data with me, only thing I know is it is following a normal distribution, nothing else. No mean, no standard deviation. How many unknown parameter I have in this equation?
Mu and
Yeah,
mu and standard deviation we don't know.
and x we know.
No.
Guys, do we know x?
No.
When I said I have my data, that means what? I have my x, right? When I say I have my data, that means I have this x1, x2,
You mean
x3, right?
yeah, you mean that standard deviation data, right?
What do you mean by standard deviation data? This is my data.
Okay.
See, this is given to me. This data is given to me, and I don't know about mu and sigma. About
Okay.
this data.
Okay.
But only thing I know, this follows a what? Normal,
Yeah.
not standard, normal distribution.
Normal distribution. Okay.
That bell-shaped curve type of distribution, and this is the equation. Now a quick question to verify your understanding. If I want to write the mathematical formula of a standard normal distribution, what is the formula? Standard normal distribution. I explained you yesterday, right? What is standard normal?
In this thing, we do the mean value as 0 and sigma is 1.
So when your distribution, your normal distribution's mean is 0 and standard deviation is 1, That is called our what? Standard normal distribution. If I'll put mu equal to 0 and standard deviation 1, this equation become what? 1 by sigma is 1.
2
E
pi
to the power of 2 pi e to the power
power
minus
minus
x square divided by 2.
4. Oh, 2, sorry.
2 sigma square. 2
Yeah, yeah,
sigma
sorry.
square. So that means what? Mu, if I put mu equal to 0 and sigma equal to 1, this is my equation, the PDF equation for what? Standard normal distribution. Okay. Apart from that, let's not like just to verify your understanding. This is the original form, not a standard normal, only normal. And we have our x1, x2, x3 data point. Now put every data point here and calculate the y value and multiply that. This is what it is saying. You have x1, x2, x3, and xn, right? Number of data points you have. You put every x1 value in the equation and calculate the y1 value. Put x2 in the equation and calculate the y2 value. Now this y and y2 value, still there will be two unknown variables. What is that? Mu and sigma, which is not known to us. Now you do this multiplication, y1 into y2 into y3 like this. This is what it is saying. Now, can you see after doing the multiplication, here is few mathematical understanding you need to develop here. What is that? When you multiply two things and there is exponential term inside it, that is e to the power a. Suppose this is y1 is e to the power a and y2 is e to the power b. What is the result of these two?
E to the
E to
power
the
a
power
plus b.
a plus b. So this is coming from mathematics, guys. Okay. So if I multiply these terms where h terms containing a exponential term, that means the power of e to the power will be added here. So that's why here it is a summation. For what? For so if we'll consider e to the power c for y3, it will be like this, e to the power a plus b plus c. Like this it will continue. So that's why there is a summation here. Okay, I'm not explaining in much detail because I know you guys will find it difficult to understand, but this is what happening here. What happened to my erase? Guys, something is wrong. Are you guys able to see my screen?
Yes, Ashley.
Okay. Now this multiplication part is done. Now we are not started the maximum likelihood estimation, guys. Okay, we are just defining that what we have and what we don't know. And this I did what? Put it, so initially I have x, mu, and sigma as unknown variable. Now then I put all the x values and multiplied it. Now I have something with this. Here two unknown variables are there, mu and sigma. And this is your equation now. I'm not my e-writer, my hand is like, okay, so this is my equation. Okay, now what my maximum likelihood estimation is saying that now what I say, suppose in a curve, maximum likelihood estimation, this can be a mu, this distribution is having mu, this distribution is having sigma. If I consider a proper mu, this is mu1, mu2, so I draw distribution in different mu. Taking different mu, I am drawing different distributions. Now which distribution is giving me the distribution I want, or which value, for which value of mu my likelihood or the probability will be maximum? How to know that? Which value of mu my max probability of the distribution will be high? How to know that?
Ashish, one question here. You said we have the data, right? So if we have the data and mu is the mean which is calculated from the data itself, then why do we say that mean is unknown?
That means we are not calculating from the population. So we have the data, but you will see how to calculate the mean here. So when you
Can
say
we
we
not
have the
directly
data,
calculate the mean from the data itself?
so the time when you say we can calculate the mean, that time how we are calculating? By summating divided by total number of points.
Yes.
So
Yes.
from where that equation or that formula come from? By summating and divided by n. That will come from this estimation technique. Okay, so when I say mean means summate all these, something happened. I gave some access to Diksha, I'm not sure. Okay. So when I say mean is summate this divided by total number, where this formula come from? How we know, like, if we'll summate this and where that standard deviation formula coming from? Summation of xi minus mu. Where this is coming from? This is coming from this.
From the data.
Yeah. No. Data is we have xi, x1, x2, x3. But how we are sure by calculating this formula, this will giving me standard deviation?
So that means here we are just like, it's a way of deriving the formula for mean or some finding out.
Correct. So this formula got derived using maximum likelihood estimation technique. That's we are going to see. And at the end, what you will see, very good and fundamental question. At the end, what you will see, if you go here, you will find this formula got derived. Can you see here? So what you are saying, we are going to do that, but using MLE, we are going to prove that. This is called maximum likelihood estimation. Because of maximum likelihood estimation, you are able to say, if I'll do this, it will give me the mean. If we'll do this, this will give me the standard deviation. Okay. Give me 2 more minutes. Let me explain the mathematics, then we'll come to this conclusion. Okay. So here, how this thing is getting done. If you see here, what we are doing, the log likelihood function often easier to work with it. That means what? In the both side of the equation, I am taking log value. Log of this equal to, so if log of this will be, guys, log of this whole term will be this value. Those who know the mathematics, are you okay with this?
Yes.
Which formula in log it is using?
First one, it's log a to the power b becomes b log a.
Becomes b log a.
And log e to the power x becomes x.
Log a b. Here one concept is log, this is a, this is b. Guys, this is a, sorry. My not drawing, actually this rewriter is not in control. This is a, this is b. Log ln ab. What is the formula? Ln a plus ln b. This is the formula.
Yes.
And in the b, in b is e to the power minus a. Log of e to the power minus a is minus log a. Log a. This is what we did actually. Okay. And so a is this part, b is this part. If we'll apply this formula, you will get n ln this minus this. Okay. This is done. Why we did? Sorry.
It's minus a, right? Log of e power
Yes, it's minus a, Ashish. Log e to the power minus a would be
sorry.
minus
A. Sorry. Minus a. Yeah, not ln a, minus a. So because ln e base, this is base is e, right? So this is 1. Right? That's why I was saying. So if I say log e to the power minus a base b. Now what is the value? Minus a log e to the power b. Guys, when I say again, I don't want to go to that mathematics. ln means what? Log base e. This is ln. Okay, you do a recap. But I know you understood, those who are answering, you understood how this got derived, right? And why we talk log values in both the side? Because in mathematics, if you have exponential, then using logarithmic, the calculation will be a bit easier. Now we are applying maximum likelihood estimation here, guys. We have not done yet. To find the maximum likelihood estimates, we take the derivative of the log likelihood function. That means this function, this value. We'll take the derivative. And when we are doing this, we are keeping other parameter as constant, because we have two parameters here, right? While taking the derivative, we have two parameters, mu and sigma, right? So derivative with respect to mu and keep sigma is constant. When you do derivative of this with respect to mu, when sigma is constant, you will get this formula, summation of xi divided by n. That is the formula to calculate what? Mean. And if you do the derivative with respect to sigma by keeping mu constant, then what you will get? Formula for sigma. Okay, here log likelihood means what? We are keeping one value as 0 and doing the likelihood, because log likelihood, differentiation of a maximum number is what, guys? Differentiation of a maximum number is what? 0. Differentiation of maximum number means what? I'm saying differentiation of constant. Differentiation of 5 with respect to dx. What? This terms means what? Rate of change of something. Rate of change of constant is always 0. So this is the logic here. I don't want to, I know a few of you will struggle to understand what is this, but this is called maximum likelihood function, where you are calculating the maximum likelihood of one parameter by keeping another parameter constant.
Excuse me, sir. That we have three types of, you told me that point and the critical interval or somewhat that before we saw. Can you please summarize at the actually the calculation of these things are not understood by me. As of me, I am just asking. Can you with that code we can easily get that, right? So I want to know where should I use this three types of what we learned today. Can you please summarize that? Sure. I can able to easily apart from the critical somewhat difficult means I want to know where should I use this. That means the very good to me.
Yeah, I got your point. So you summarize, instead I summarize what you understand by point estimate, what you estimate by interval estimate. Forget about MLE. Tell me about this. When you are going to use these two, in which scenario? What you mean by point estimate and what we mean by interval estimate?
Point estimate, it gives the that when at the time what you have understood is the number variations if it is high means that is if better you say, sir. I'm not
no. See, that's what you have to try it. Okay, if I will explain anyone Niveda,
if we have a large amount of population, we cannot find that mean and variance point very easily. So at that time, we need to have these types of estimators to calculate these points.
Right. And point estimates means what? It is easy to calculate something that is not going to change, right? And I think I have given some access to someone. They are also trying to. So I have by mistake I have given some access actually. I'm not sure to whom, but yeah. Point estimation means what? Again, this provide a single value estimation where you are not confused or there is no chance that this estimation is going to change. Like
Yeah.
You can say a sample estimator, like your sample data. There your sample data, the mean is not going to change, right? The
Yeah,
mean is
before you told that we can have mean can lie between any points between these to these point, but it gives a particular point, exact point.
correct. So if you see for sample data, we went for point estimation, correct? For sample kind of data where the mean and standard deviation is not going to vary because that is the particular sample I have, right?
Yeah.
But if we have, you are calculating mean value of a population data, which is a larger amount of data, where you are not be sure whether the mean will be at this particular value or not, because sample size is small, you immediately calculate it and say 5.5 is the mean value. But you have the population data, larger part of data, there the surety will not be there. So the way of representing the mean value there is what? Interval estimator. That you will have some confidence labor and some interval. In between that interval, you will say, here my mean is falling. And when you are using MLE, okay, actually the answer of this is lies in here. Divya, you are there?
Yeah. Now I got it, sir.
In general, point
sorry
let
to
me just 1 minute, give me
okay.
let me read this out. Okay, in general, point estimates are used to provide quick and easy summarization of a sample. Interval estimation provides a range of what is this, pulsable values of unknown parameters. Range. MLE can be used to make inferences about population parameters, and it's particularly useful when the underlying data generating process is not known, when the traditional statistical assumptions are not met. Yeah, Dinesh, you were saying something. Sorry, I stopped you.
Yeah, that's fine. That point estimator will help us to calculate the you know
Quick
with
and
this.
easy summarization of a sample.
Okay, easy summarization of a sample means we can get the easy with a point estimator, we can easily get this mean and standard deviation of the data.
Yeah, see here, this is important, sample.
Okay.
And
so if I'm having 1,000 line of sample data means like yeah, that time I can easily know because I know my data size and I know my data clearly. So I'm using if I'm using the point estimator means I can easily get the mean and the standard deviation of my data.
Correct.
Okay.
But if you have population, then there this point estimation won't be feasible, or that
Yeah,
not
because I was not sure about my data, so that time I supposed to use interval estimation as we did, like 90%. Like I'm taking 5 states and then I'm calculating the interval estimation with the confidence level and all those. Then I can get. But with the MLE,
can you read it out? It is particularly useful when the underlying data generating process is not known. What does that mean? That means your data set, about your data set, you don't know anything.
okay, it is a
That time
population
what
data
you will
or
do?
okay.
You just need to, you only know what? The types of distribution.
Okay.
Okay, like even if population distribution you are going for, you only know your population distribution following a normal distribution.
Okay.
And you do this for what? Not only for, this is one example, if your data following normal distribution. If your data following exponential distribution, then what changes you need to make here? First of all, this equation will be changed, isn't it? So what we did for normal distribution using PDF of normal distribution, we can do the same thing using PDF of exponential
Oh,
distribution.
now only got to know. Sir, sorry, you go. So it means that if we know the what kind of distribution, then that point and interval estimators we used to implement. If we don't know what kind of distribution itself, we have to use MLE.
No, see, point estimations and your interval, sorry, MLE and interval estimations have their respective advantages and disadvantages. Okay, both are kind of similar, you can say. But here in interval estimations, your population data, population distribution is not what? Mandatory. Whether your population distribution is following a normal distribution or exponential distribution, that we are not considering. How we calculate the confidence interval? Did we do something like normal distribution or exponential distribution stuff?
No,
We
we've
just use
only,
what?
yeah, we only
Use
using
sample.
sigma. Yeah.
We use sample, then that using that sample plus minus we did, right?
Yeah.
Critical value, then sigma and mu of sample. We are not bothered about the
Excuse me,
distribution
sir.
of the
Sorry to bit you off. If you give the example for MLE means the situation, I'm just asking the situation. Point estimate, we know that examples sample data is there. We are calculating the mean and standard deviation and all those things perfectly. That means point. Interval estimation means that a huge amount of data when we have, we are predicting this using interval estimates. You just give an example means will be clear this too.
No, so that part you try to find out the example. There, in that way, you will do a research externally. You will understand MLE again. Okay, like
Right.
tomorrow
So
we
sample
can.
data.
I can take also one. I can explore one example. I can tell you tomorrow. But meanwhile, you also try to find out.
Okay, so for point estimate, for a small amount of data, we can use point estimate. For interval estimate, we can use a huge amount of data, but still, if we have an understanding about our data, then we can use it. Like even though if we were not sure about our distribution, I think
Right.
for the MLE, we can say take the same example. I'm not sure that this is correct or not, but for MLE, like in the case of MLE, like I don't know how much data I have, like 10 million or 1 million. Like I don't know about my data, but still I know the distribution of my data. Like okay, I'm having a data and that MLE was like my data was following a uniform distribution or a standard distribution. That time I can use the MLE, right? I
Right.
know the distribution, but I'm not sure about the confidence in interval.
Correct. So guys, to everyone, okay, whenever you find any difficulties, you utilize this, okay, Google, and see, you have to go through this, the blocks, okay. What is MLE? What is the use cases of MLE? Right. So this is where your understanding will be increased by referring before, and your patience, your reading skills also increase. So these things I tried my best to make you understand. Now after this, do a practice to explore yourself, okay, because after 2-3 months you won't be there. Okay,
Yeah.
you have to, every new concept you have to look it, and no one is going to tell you about the new concept. Maybe this concept is known, that's why I'm explaining. Suppose in some new concept came, how you will understand that, right? So try this practice, okay. Go for this URL, what we understood in today's session and what they explain in their blog, whether
Sure,
this is
sure.
matching or not. Okay,
Okay.
what discussion, what example we took and what they discussed. Refer these blogs, refer the videos here. Okay, and best way I found in this statistics is like videos. People have explained, okay, in videos with 10 to 15 minutes. This is more effective than going through the blogs and all, and time saving also. Refer these videos, what they said about maximum MLE, where they used MLE, where they used, then only your what
Understanding will improve.
understanding will be developed.
Mm-hmm.
But I'll also try. Okay, today I'll also try to find, if I'll find a very good video, if you find also, you try to share with the whole class. That is also one good thing. I'll try to find with examples, because in this notes I don't have examples, and I also don't want to create my examples. That will be super confusing. So let's see.
Sure, sure,
Actually,
Ashish.
this MLE concept is like breaking the brains.
Huh. So this statistical concept is
It's
like, so
not
I
only,
told
yeah,
you, right?
like when that statistic thing was started, like I was literally
See,
banging
guys,
head.
people are completing this with in semesters, right? They are doing research
Yeah.
on this, and we are studying this in one section. That also
But the
this
only
is
thing
what.
is, like, you are explaining all those, and then we have that program, right? The only, the only thing that I'm saying myself is, okay, you're not going to do these all, like you're just going to do this codings. So just focus
No,
on
no,
that coding, then it
Yes.
will be fine with that.
but knowing the things is also important, guys, right?
Yeah, yeah,
Like what is happening in the background. You can use these codes and do, like, see here I have the code to show you how to calculate the standard deviation
yeah, yeah.
manually, right? You
Mm-hmm.
know this, but if you don't know how this is getting calculated, or what is the logic behind this function or
Okay.
formula, so there's no use. Even if something will change in distant future, you won't be able to explain that, right?
Yeah, yeah. Like
So that's why.
yeah, I'm going through these videos again and again, so that like, okay.
But yeah,
This
but
was
yeah,
this was the whole topic in one semester, like a
right,
discrete and
right.
continuous
Correct, guys.
probability, one full subject, which was
Full subject. So people are, that's why I told you. So when
Yeah,
Divya said, please give us example, you explore. When you explore, you will get to know how these
what is
topics are
what? Yeah,
broadly
yeah, yeah.
divided.
Yeah. Like
Okay.
these things are, yeah, these things are too broad. Like when we talk about fund, like in mathematics itself, we have a lot of stuff. Like in statistics also, we have a lot of
Mm.
branches and all those, right?
Correct, correct, correct.
Yeah.
So so this is also one way to practice, guys, because to be honest with you, I have referred so many videos, so many blogs. Even if still also you will not be clear. That is also one possibility. But that time you have to keep the patience, okay? Because
Sure.
sometimes eventually it will come, not that particular time. But if you realize you didn't know coding at the initial state, but
Mm-hmm.
right now, if someone will give you the code and try to tell you that explain me this code, this is now easy. But
Yeah.
that time, if you remember, that time it was very difficult. What is this code? How will I learn this? So
Yeah,
it will
yeah, yeah.
come eventually by time, so don't worry.
Yeah.
Yeah,
Ashish, can we,
yeah,
jump
yeah,
into
yeah.
that code,
Chat
or
now,
you
chat
have
now.
a work?
No, 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 no. We can go that. Can go there.
Yeah.
Let me. What I need to do. Let me stop sharing. Okay, all
Yeah,
my
yeah.
screen will be slow. So what I'll do, I'll open that code, because that code I ran actually. Divya, you ran that code.
Yes, sir. Which code,
That
sir?
That
one to one
MongoDB
and one to
one
many.
to
Yeah,
one
yeah.
and
I ran it, sir. Yeah, yeah.
is
I
it
ran it.
one to many? You ran, right?
Yeah, I ran it, sir. I ran it, sir.
Can you please share your screen if you don't mind?
Yeah, sure. Sure, sir.
So, but that one to many, Divya, you copied from the text, right? Or did you change anything?
No, I didn't change anything. After you giving the final document, I used that.
That is great. Then I'm not sure. Okay, so let's see her screen, because updated code was the one to one is running for you, Dennis.
No, Ashish, like that was also not running for me. I think I've created a connection, and then yeah, I've created a connection. Let me
No,
run
no, you
this
share
once.
your screen. Meanwhile, Divya is setting up her environment. You share
Uh-huh.
your screen at one to one. Let's see what is
Sure.
happening.
So let me know if you're able to see my screen. Yeah, I hope you can able to see my screen. Do you, Ashish?
This is done. Go for one to one. This is one to many, right?
Yeah, okay, let
One
me
to
go to
one.
one to one. Yeah, one to one. Okay, where it is?
Insert
One to one, one
one.
to one. Yeah, here.
Hold on, my reference personal details insert one. Here itself it is showing some error, right? What is the error
Yeah.
while inserting?
Commas.
Collection object is not callable if I'm all insert one. See. Go up. Insert one. Actually, that is.
Insert underscore
Yeah,
one.
yeah. Let me change it.
But I have
And
changed these
also,
things. I'm not sure. So Divya, I changed this whole query, right? Or you need to also change these things while
Yes,
running.
I'll share, sir.
Okay.
I think
Okay.
in this it was not updated, it seems.
Then where I
But
updated?
no,
Then
you have changed that. First, you send us the one link. After that, you give me the final, that correct one you send me. Send off to all of us.
okay. Dinesh, can you please stop?
Yeah,
Actually,
let
I'm also
me.
getting confused. I have a feeling like this is not that code that I provided to.
Yeah,
Yeah.
like
feeling like
you have updated, like if you have updated, then it also updated for me, right? Because we are having the chat link.
yeah. Kiran
is,
is also saying something. We can't see your screen. Yes. First of all, before that, Divya, can you show the document that you referred?
Yeah,
And the
sure.
so that
Uh-oh.
But I think 19th or somewhat. I don't know the exact date.
Let me give that to you.
26 June, right?
Yeah,
Can you open
26th
that?
June.
Open that one.
Yes, yeah.
Ah. So Dinesh, 26th June file. Refer that one.
Embedding.
We are
Okay, 1
referring
minute.
some old document. That's what I said. Like I changed it. So 20. Which one? 28th, right? Or 26th? Refer
26th,
that
right?
document.
Session 1926. Okay.
20. So June 28th, I modified it. And the file is under 26. Now this will work for you. Yeah, this
Yeah,
will work.
okay. Yeah, now I can see. Like I was referring that, and if that was
So I
modified
also
there,
got
then yeah.
confused.
Yeah,
Because
if that,
I myself
yeah,
I
Ashish,
modified
can
this.
you please, yeah, can you please, drop these two files in there and delete those if you're able to.
No, actually there is some confusion, guys. I am also getting confused. Divya, this is folder date with 26 or 28.
This is with 26 actually.
This is
That means we
26,
have
sir.
another folder which contains the old data that I need to delete.
Yeah. Let me give the data to you. I think that is on 28th or what? 2016.
Okay. Let
This
me delete that.
26th.
26th Divya is referring. That means we are referring some older date.
Yeah. Let me find that one. 22, maybe session 18, 22. I think. Let me take a look at it. Yeah.
Here we are
Find it.
another
Yeah, found it. Yeah. So Ashish, actually you're supposed to do, you need to replace the session 18 with the new file. Session 18, 22nd. Like actually in 22nd also these files were there, and 26th also these files were there.
Okay, I got it. So I need to replace the older one also. I'm
Yeah.
doing that right now. So that
Okay.
also I will do. Okay, that also I'll do. 18 session 18. Okay, let me do that. I'll do that, guys. So now you got the new query, right?
Yeah. Now
Try
I
to
got
run
the
that.
new one. Let me try it.
Yeah, quickly try. Meanwhile, I'm updating.
Okay. Let me get into 1926th. Data
Session
relationship.
18, 22nd.
One to many. Okay, so let me try one to many first.
Data relationship. So I think I have to delete this. They do not need data relationship in that session because we have that in another session. Remove it. Silpa left, right? Silpa left. Silpa is here.
No, I think she left.
She joined from the evening batch to this batch, but they have already completed module 14. I'm not sure why she joined, but yeah, not sure. So she also needs. I did it. I deleted it. Great, guys. Great. I hopefully tomorrow will complete the hypothesis testing so that we can continue with our other journey. I can feel like you guys are like
Yeah,
statistics
like
and
yeah, actually I was totally going down, and I'm like, like I was thinking like, okay, did I made a mistake of joining like that? And then I was like, talking with my brothers and who all are working in IT. Then they said like, no, don't feel like that. Like in here also there is a people to teach you. Like, okay, you do have a colleagues, they'll help you. But while you are studying, please don't think about jobs and all those. Like focus on how
definitely
much you have.
very good suggestion. Very good suggestion. Because
Yeah, they were saying
I
like,
told you, right? At this
yeah,
particular time, you may be feeling restless or pressurized,
yeah,
but
yeah,
eventually, after 1 month, if you'll see, no, you have
yeah,
this knowledge, and that will come.
yeah.
You don't think about it, no, it will
Yeah, they
automatically.
were saying that like don't think about anything. Like consider that you are in a college and you have a semester exam. So for that
Right.
semester exam, you have to prepare yourself. If something happens, then you have
Yes.
RES. So try for like study for the RES, then clear the
Yeah.
exam. If you
Right.
failed it again, like that,
Correct.
my
Correct.
brother was
Correct.
saying.
Correct. The totally good suggestion to
Yeah,
all of.
because that guy was working in Microsoft in the
And
US.
one, excuse me, one more thing I want to share with you. These kind of things also happen to me. But
Hmm.
yesterday I have read one article in Medium that sir
Right.
told.
Yeah,
In that they wrote one article. What they told in that article means,
yeah,
even though data scientist job is also the uncertain things are going now, but you
Hmm.
don't worry. AI will help you to do all the projects, whatever the field it may be, but the person they need to do that. That we have
Right.
to give the command to AI, right?
Right.
So you
yeah,
don't worry about that. You
Hmm.
just develop the skill to how to
Cope up with the
deal with the
situation.
yeah,
AI.
yeah, yeah.
Cope
Yeah,
up with
Totally,
the
yeah.
totally.
situation.
Because like I told you, right, my brother, this guy was working in Microsoft. So this guy was like, he was like studied so hard and did all those stuffs. Like I think it took him so long to get in. Like he worked in Freshworks, then he shifted to
No,
Microsoft.
you can also achieve this. Don't worry.
Yeah,
Just consistent on this, as you
yeah,
know
yeah,
that article Divya said. No,
yeah, yeah,
like
sure.
people are unnecessary fearing something. That's the problem here.
Yeah, because like I was
Huh.
feeling like I was felt like, okay, what if I can't able to do like what
Hmm.
one day you said, right, like if you understand then it is fine. If this is your cup, then you can understand. Like that day, like I won't say that like you like because of you,
Do
I lost
so.
the
The
confidence and
thing
all
is,
this.
you
Hmm.
keep
Uh-huh.
studying, keep your mind
Okay,
open till the last module because
okay,
lots of things are there. This is just starting,
okay,
guys. Okay,
okay.
lots of things are there, and you'll see it. So be
Okay, okay.
patient.
And also like I have a mind block, it seems like I have a mind block of, okay, this may be a problem, this may be a problem, like that I'm
It's
feeling, it
not
seems.
your problem. This is a
Yeah,
common problem to whole like human. It's a human nature. It's in nature. We
yeah, sure.
always predict something which has not happened, but we
Yeah.
predicted in our mind, and this is
So
called.
yeah, I supposed to keep myself open and like nowadays what I'm doing, like for the past 1 week, I'm just logging into my work and I'm not doing anything and I'm studying. My team leader was
Study.
literally, yeah, I'm,
Learning and studying, reading.
yeah,
These
yeah.
things you have to develop.
Yeah,
Okay,
my
as
team lead
I
was
told
like,
you, right?
"What happened to you in this week? Like, you haven't done anything. What are you doing?" Like, okay, fine. If you are working, or else if you're doing some works, extra works, or you're doing course, that is fine. Please don't let it affect your work. Please try to do
that's
something like
that's
that. You
you
were
that's
saying,
that's balance you need to keep, guys, right?
yeah,
So if you'll that's why like last 6 months like I totally detached from the job and totally because it is not time yet for you. Okay, there's so many stuff you need to understand. This is just
yeah,
starting. So
yes,
make yourself ready, make your
yeah.
mind and physical and mentally ready.
Yeah, like it took me this time, like I think it's more than 1.5 month. I think I've joined in this course. Like now only I'm getting ideas like how to study, how to do. Like
Correct.
I'm reducing my sleeping time and all
And
this for
also
the
I think
past
this
one
is
week.
not going to be a 3 months for you guys because
Yeah,
the rate we are going, It
Yeah,
is
yeah,
not
yeah.
going to
Totally,
complete.
totally, totally.
So it will be bit more than that.
Yeah, already they said that it will be around 3 to 4 months. So if it is going far also, like that is fine. If we were going slow, then we were gaining a more knowledge, right?
No, the thing is, you
Mm-hmm.
just need to keep that momentum. This
Sure,
course
sure.
is helping you to give that momentum, that
Mm-hmm.
direction where you can
Sure, sure,
carry
sure.
on and focus yourself. That's
Sure,
what
sure.
I found. This type of courses are helping people not in getting every concept, but a direction or
Sure,
the
sure, sure.
momentum. Like the
Mm-hmm.
momentum. Okay, I
Like
need to finish this.
as per me, like I'm clear with Python, Pandas, MongoDB, and SQL. Like I'm struggling in NumPy. So if I do
See,
something with it,
NumPy we are using in the code, right? When I
yeah, yeah,
explain, I'm
yeah,
using
yeah,
it. So
yeah,
that is the only thing. Nothing apart from that.
yeah,
That's it.
yeah.
Using NumPy and SkyPy, we are
Mm-hmm.
doing some coding. No, that is one type of exercise and practice we are doing.
Yeah.
So don't
So
worry
yeah,
about
yeah,
this
yeah.
NumPy.
I hope you can understand like how much overthinking that
That's
I have.
why. See, that's why, like I also started like this, right? So
Yeah,
whatever
yeah.
you are feeling, I already
Uh-huh.
explained. So
Uh-huh.
that's why I'm able to tell you this.
Because like I have another profession in my hand. If something goes wrong in here, I have to cope up that also. Like I
No,
don't
no,
know
please
what's
keep that
happening with
balance.
my, yeah, because I
Keep
don't
that.
know what's happening with my work also. Like when I've started to study here, like my work was going hectic to the core. Like yesterday and all, I was literally dead.
No, no, no. Please keep that balance because I
Yeah,
know, and
yeah.
I'm know we're like also managing the family.
Yeah,
Like
like the cat on the wall.
hats
Like
up to them
yeah,
because I'm not sure how they
Dinesh,
are
don't
doing.
worry. Yeah.
like
Actually,
actually the
you
thing is
are
like
you are better than far more people. So you
yeah,
are
thanks
actually
for your words.
working
Thanks for
and
your words, and thanks to
uh,
you. I was just like because like, I
No,
was
no, no.
overthinking a lot. Like I supposed
And
to like
always the women's are like always respected. How they're managing all this stuff, I am also not able to.
yeah,
Imagine that maybe some
like yeah,
higher
we
power is
yeah
helping
we
them.
do have
But hats
the
off to
people's
them
right.
as
Yeah.
well. They're managing and they're studying.
Hmm.
So I'm not going to comment
Yeah,
on that
me.
part.
Yeah,
But we
yeah.
need
The
to learn
one
from them.
thing, excuse me, the only thing yesterday also sir told, you just don't worry about now. You just complete the all modules and then you have the clear idea,
Correct.
like the way he told. So
Yeah,
don't
Right.
worry.
yeah,
Yeah.
yeah.
Now
That's
I
today's
think
yeah.
class
I
also is
think
hectic.
yes, I
Uh,
think we should listen to the words of Dhoni. Don't look for the results.
Yeah,
Yeah,
no, see
maybe
this.
like maybe I have a superpower, which is overthinking. That's the
No, no,
problem.
Yeah.
overthinking is a common problem, guys. Overthinking is a common problem, and you will
Hmm.
overcome it. Okay, you
Yeah,
don't
yeah.
worry. So
Sure,
once you
sure, Ashish.
started, because after this session, no, what the
Uh-huh.
topics you have, you need time, and automatically
Okay.
you will spend time without worrying about how many hours
Mm-hmm.
you're spending.
Mm-hmm.
Automatically, it will be there
Yeah,
because
because now I
topics.
can see like if I'm seeing something, if I'm seeing an AI also, like I'm thinking like how these things were working, what all they were doing. Like
Hmm,
I was thinking like that if I'm seeing a
eventually,
program, like I
it will
was
come
thinking like
eventually.
yeah. So
No risk,
let's
no
see.
risk, no risk,
Yeah,
guys.
thank you, Ashish, and thank you, Nuet and Divya for giving me,
don't worry, be
confidence.
positive. The positive energy will give us energy to work or to learn or
Yes,
anything.
Yeah.
That's
actually, Dinesh, you are having a work experience and you are doing this. Think of many people
we
like
both
me.
are not having that too. So you are better
We
than us.
even haven't worked or even single day
See, you are
don't have
getting
Oh,
any
this
work.
much
thank you.
motivation,
Yeah, yeah,
Dinesh.
yeah.
You're like,
Thank you. That's so
no
sweet
other
of you guys.
platform can give you this much
Yeah,
motivation,
yeah,
right?
that is so sweet
Great.
of you guys. And
You
Ashish,
That's
know, half
thank
of
you.
the class, my children used to sit on my lap and I used to hear with one headphone. And
Even
okay.
today also it's happened.
Not sure.
Oh,
Like these are
I oh God,
like
like you guys are totally like in another level. So yeah, I'll take you guys as a inspiration.
yeah,
Then
yes, like all of us. Like I
yeah,
always wonder. Like Sleepa, she came knows in the evening match. She also has her kid. So like the kid will do the peeing and all every time. She will keep
yeah,
speaking in the
that's
mic.
the problem why I also joined from evening session to morning session.
okay. So
Guys, you
you
guys
guys
like
have a
hats
lot of
off to
things.
you.
Like I'm only having a
Uh,
work, and I'm
whenever
yeah.
we used to sit with a lap, my daughter or son will come and say, I'm hungry, give me that, give me that.
Oh
I want the
God.
phone,
Yeah.
data, everything.
I
All the
used to have
problems
that
will come.
problem with my siblings. Like if I'm
Do
going
you
there,
now have any complaint, Dinesh? Like by
yeah.
hearing
Like
this, do you
I
have
can
now
totally
any
get it. Like
complaint to your life?
because
You are
on
more
Monday,
comfortable.
Yeah, on Monday I wasn't attended the class, right? Actually, that day I was in my sister's home, and I have my sister's kids. Like my niece was there. Like these two people were on the day they had a day like holiday. So I've started like they have turned off the Wi-Fi. I was like looking what has happened to the network. They turned off the Wi-Fi and they were saying like you are always
Children are
sitting
like
on the
that.
laptop. Yeah,
Children
you
are
are
like
always
that.
sitting on
Children
the
will
laptop.
always.
You are always sitting on the laptop. Come and play with this. So they had just gone there and turned off the Wi-Fi. It seems. I was looking like a mad guy and I was searching like what happened to the network. Then only I'm looking like the Wi-Fi was
Right.
turned off, it seems.
So the thing is like they will teach you the patience, right? That these people are already
Yeah,
having.
yeah, yeah.
So that
And
remains
thank you guys.
patience, guys. Okay, so immense
Yeah,
patience and be confident
sure,
and
sure.
consistent with your learning. Because
Yeah,
still I
yeah.
am also learning. I have to refer 1 or 2 block every day to
Uh-huh.
understand what is new happening in the industry. Because
Sure,
then only we'll cope up with that.
sure,
Or
sure.
else you will,
Yeah,
you
like
know.
he used to say, my brother, he used to say the same thing. Like you have to be updated. Like if you are saying that your passion is to work in IT, if you are coming into IT, you always have to be keep studying. You have to be keep updated
Correct.
yourself. If it is not, then you will be thrown out of the like you will be
No,
thrown
you
out of the track.
automatically will get out of my.
Yeah.
So the teacher he told me specifically, if
Uh-huh.
you don't updated with the recent technologies, you are going to be dinosaur.
Yeah.
That's this is the word. Dinosaur means what? You are going to extinct. Because if you
Mm-hmm.
don't get yourself updated, see, Chat GPT came,
Yeah.
Chat GPT 3.5 came, now Chat GPT 4 came. That is totally
Yeah.
different than 3.5 within fraction of months. If
Yeah.
I only using Chat GPT 3.5, don't know about 4, people will not consider me because people know Chat GPT 4.
Yeah.
So always be up to date with the recent technologies, refer, keep reading. That's all. Like make a
Sure.
practice, dedicated some time in your day or week. You have to, I have to read research paper.
Mm-hmm.
Okay. So I am reading actually research paper that is getting invented. Immense patience you need to read that.
Okay.
But
So
you don't do
first,
that right now.
yeah. So
You
first, I supposed to like look for the YouTube videos, then the blogs, then the
videos, then
research
small
papers.
blocks that as Divya is
Yeah.
also
Medium.
referring,
Yeah.
right?
Yeah.
Medium blocks. So
Yeah.
that will increase your patience level, and
Mm-hmm.
gradually after 5 to 4 months, you will be sit and you will forget about the time. You'll keep reading, and 1 hour will be passed like
Sure.
that.
Sure.
So
Sure,
that will
Ashish.
come eventually, not now. Don't
Mm-hmm.
worry right now.
Sure, sure, sure. That means a lot. And yeah, I think I'm taking a lot of time of you, and I'm,
No worries, no worries. What is the
I
time?
supposed to
Oh
thank you
God,
guys. Yeah, yeah, yeah. I
11:40. Okay,
supposed to
let's wind
thank
up
you
the call,
guys.
guys.
Sure,
Thank
sure,
you,
sure.
guys.
Thank
Yeah.
you,
See you
thank
So
you.
tomorrow.
Ashish,
Yeah.
before you wind up, like I just want to add one line to
Sure, sure,
everybody's benefit. See, like when
sure.
I completed my master's, I learned
Mhm.
SAP for 6 months and I got a job as a SAP consultant. But what I
Okay.
learned and what I was doing as work was totally different. Okay, so if I
Okay.
if I learned 100%, I was just doing 2 or 3% of the concepts I
Sure.
learned. So the
Definitely.
same
That
will be
happens with the
here.
work.
Yeah,
Yeah.
same will
Definitely,
be here.
definitely.
We need to keep the concepts and the knowledge, but the project
Sure.
what we will get into that will be different.
Yeah. Thank you,
Similar,
Kiran.
I
Thank you.
told you, right? Like
Yeah,
one of
yeah.
my friend
Like
example, I told
yeah, we
he's
all
taken that as a
faced it.
data scientist, but they started telling him to manage the team. No
Yeah.
deep were there. So yeah, this real life example means a lot actually. The experience you
Sure.
guys are
Yeah,
sharing
yeah. Like
actually.
I've also been in that situation. Like I was working as in client relation kind of guy, but now I'm working as like I'm
Mhm.
managing the people and I'm working like in HR sometimes. It happens.
Okay, okay. Thanks for
Yeah.
sharing that,
Thank
guys.
you.
Thank
Thank
you.
you.
Yeah,
Yeah.
yeah.
Thank you, guys. Yeah.
We'll see you tomorrow. Yeah.
Yeah. Thank
Bye.
you, Kiran, once again.
Yeah, thanks a lot. Bye bye.
Bye bye.
Have a nice day.